We're going to do notes for pre-calc, lesson 1.6, graphical transformations. I'm going to move some things around. You can take a look at a few of these things on your graphing calculator as well. You can see what's happening. Some of it's going to be review from Algebra 2. Some of it might be slightly new. But all of it we've worked with before in one capacity or another. If you're going to graph the following on a coordinate plane, if I'm going to graph y equals x squared, we should know it's going to be a parabola. Its vertex will be at 0, 0. If we're going to graph x squared plus 3, I'm going to go up 3, and I'm going to have a parabola. It's going to go open up. It's going to be 3 units up. X squared minus 5, down 5, opening up. Basically, all my y coordinates are decreased by 5. So our transformation is up 3, up or down 5. None of that should be a surprise to you, as we have worked extensively with quadratics in the past. We've also done these other guys right here. If you remember back to Algebra 2, that when you add or subtract inside the parentheses to just the x value, it's going to make it go to the left and to the right. But it's an opposite idea. So if you type this into your calculator, it would move 2 units to the right, and then we have our parabola. Looks something like this. Kind of ugly. It works. Our vertex is 2 to the right. When we talk about x plus 4 squared, 4 to the left, and we graph our parabola. 4 units to the left. Remember, this is kind of like a 0. This is actually a double root. 2 lies on the axis. Negative 4 lies on the x-axis. So when we're talking about the parent graph, we're talking about x squared, and then we make these descriptions in terms of where things go. If you remember, I'm going to negate all of these values, then we are going to open downwards. A negative in front of the function is going to reflect it over the x-axis. And then one like this. How are we changing the parent function? I would say it's a reflection over the x-axis and 4 units down. Those things should not be necessarily new material. If I just gave you these, up 3, down 5, 2 right, 4 left, reflected over the x-axis, reflected over the x-axis, and 4 units. Oh, this one should have been 4 up. Holy cow. Did I make a mistake? That might have been the first mistake of the year. Plus 4. Oh, geez. I'm glad I caught that. 1, 2, 3, 4. This is up 4. This is the reflection over the x-axis, also known as, we're going to flip it. So that's going to look more like this, huh? Is that better? Where my vertex is 4 units up. Hoofda! Would have hated to have had that mistake on this video for the rest of time. That would have been a setback to the old ego. All right, good catch. Good catch. General idea then. We have if we are adding and subtracting to the entire function, we are going to go up or down. So this would be like the y equals x squared plus 4. That's going to be up 4. when I add or subtract to just the x value, then I'm going left or right. So it kind of has to do with inside the parentheses or outside the parentheses. Now I'll graph these. Or please notice the 12 basic graphs that we had in 1.3. All of these, this pattern will hold true for all of them. We'll use this for the entire class. Square root of x. So remember, the square root of x looks like this. It's like square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and so on and so forth. But, you know, this one on the outside, that's going to be up 5. This guy on the inside is going to be, and that's an opposite idea, left 5. You can graph those if you want. The plus 5 would be, if that's 5 there, you know, we're adding 5 to the entire function. The other one would be 5 left. If you go 5 left, look like that. Graph those on your calculator, and you can see what's happening. This says the same thing. 5 units, or C units right, C units left, C units up, C units down. Vertical translations, again, absolute value, that's the graph is the V, and it's going to move the whole thing 4 units up. It's on the outside to the entire function. Next, it says each view shows the graph of y equals x cubed. That's going to be the red dotted line on each of these. Write the equation for each of them. I look at the first one here, and it looks like the whole thing has been moved down 3 units. So I'm going to say this first one is going to be y equals x cubed down 3. There's the first one. Next one, I appear to have moved 2 to the left. That means I'm going to have to do it inside the parentheses, and it's an opposite idea. So I need plus 2 cubed in parentheses. Next one appears to have gone 3 units to the right. Again, to the right, opposite idea. I need it in parentheses, and I need it minus in there. Should be good right there. Hey, look at that. We got them right. Give yourself a pat on the back. If we negate the entire function, we reflect over the x-axis. If we negate just the x value, we reflect over the y-axis. Sometimes this second one is a little bit harder to see, because if you're talking about y equals x squared, if I negate just the x values, you can't see anything. The original function is right there. The new function, if I negate something that's going to be squared, it's right over the top of it. But in fact, all of the values were reflected over this y-axis. It's easier to see when we talk about. Here's y equals the square root of x. If I negate the x values, I'm going to reflect over the y-axis. I'm going to need to end up over here. I'm not allowed to take the square root of a negative. So if I graph, this one would be y equals the square root of a negative x. Think about the values that would have to go in there. I have to take the square root of negative, so I'm going to have, all my values are going to need to be negative. Put a negative 1 in there. Negative 1 is 1. Negative 1, 1. Put a negative 4 in there. Negative 4 is going to be positive 2. So a reflection over the y-axis, I went to the left over the y-axis. This guy over here, this is the one we're used to when I reflect over the x-axis. If I do y equals negative x squared, negate the entire function. Now I open down, which we can see there, but in this case, y equals negative x squared. If I negate the whole function, now I'm going to reflect this direction. This would be negative square root x. I'm taking all of the values, taking the square root of them, and then I'm making them negative, which means the y's all end up being negative. So there's a little difference between if you negate the entire function or if you negate just the x values. And if you think about it, reflecting across the x-axis, if I'm negating just or negating the entire function, that's the y values. The y values end up having sign changes, and that's why we go up and down. And when I negate across the x-axis or the y-axis, when I negate just the x values, that's x values are left and right, and that's why we reflect left and right. The next one can be this can be a little bit, I'm not going to get too hung up on this because sometimes it's going to be hard to tell whether or not they are originally talking about a horizontal stretch or shrink or a vertical stretch shrink. So if you can recognize whether or not we're going to go up faster or down, up slower, if I'm going to be wider or narrower, that's going to be the important thing here. This just has to do with, are we dividing the x values by something, or which is a horizontal stretch or shrink, or vertical, multiplying the whole thing by a value. So if you think about y equals 2x squared, I took the x squared and I multiplied it by 2. This would technically be a vertical stretch because we're going to go up. Stretch is going to be faster, okay, for vertical, going to go up faster. And then the horizontal one gets a little bit confusing, but I will make sure that we are all on the same page there. Let's just take a quick look. If we're going to follow the rules that they just gave for me, it says we're going to start with y equals x cubed plus 3. And then if we're going to stretch vertically by a factor of 4. So I think vertical stretch, that meant, if I look right here, I'm going to multiply the entire function by the value. So let's do that now. So C2 is what we're creating. C2. Take the entire function and multiply by 4. So I get 4x cubed plus 12. Horizontal shrink by a factor of 1/3. Now if you looked at that, that said take just the x value, so C3, take just the x value and divide by 1/3, which is a little bit awkward to us. And if I'm dividing by a fraction, flip the second guy and multiply, I'm actually going to have 3x cubed plus 3, which is 27x cubed plus 3, right? Here's the ambiguous part. So here was my vertical stretch by a factor of 4. Here was my horizontal shrink, which also goes up faster. If I just gave you this one right here and said describe the transformation, you would tell me if I started with x cubed, I went up 3 and a vertical stretch of 27. How can I tell with the end result whether or not it was a vertical stretch or a horizontal shrink? I can't. And therefore, can you tell that the 4 makes it go up faster by a factor of 4 and the 27 makes it go up faster by a factor of 27? Absolutely, you can tell that because we're multiplying by a number greater than 1. So really, I'm more concerned with, can you tell whether or not the graph will be going steeper than the parent function or wider than the parent function? That's really what we're concerned with. Okay, did we get them right? Hey, we got them, woohoo! Okay, combining the transformations. So it says I'm starting with x squared. It does say we want these in order. So I'm going to start with x cubed. It says horizontal shift 5 units left. So I'm going to take my x and I'm going to go left, which means I need a plus 5. And I'm going to square it, vertical stretch by a factor of 3. Take this, multiply it by 3. Vertical translation, 4 units up, plus 4. I have done everything in the correct order. Order of operations would tell me inside the parentheses first, multiplication second, and addition third. We are good. They expand that out. Here's the answer that we got. I'm not concerned about expanding out. I've got no problem with leaving it as the 3 times x plus 5 squared plus 4. Okay, that's the end of 1.6.